Hey, how you doing? This is OXDF, and today we're looking at the advent of code 2015 day 7, some assembly required, and we're doing it in Rust. Um, let's go ahead and take a look at the prompt. Basically what we get is we get a whole bunch of wires that have like these bitwise logic gates, right? So each wire, so each thing is either is an output, and then it tells you how to make the output from one or two inputs. So for example, they give you, if you have x and y equals z, that means you take the value at x, the value of y, you AND them together, which is a bitwise operation, and then you get the output to get z. And so you can have things like 1, 2, 3 goes to x, and then you'd also need to find like where's something that inputs to y, and then you'd AND those two values together and you'd get z. But y could be, something else, right? So let's come down here. You know that, well, in this case, y, you get a value for y and a value for x. So you can then make E and D, and you can, figure out these different values out of it, and then you create these values. That example is really kind of small. If you come over here to the puzzle output, they have a ton of stuff, and the answer to the question we're looking for is what's the value at A? But we're gonna have to go back hundreds of unwindings to get what A is. So strategy wise, we're going to create we're going to create a gate object, which just has an in1, in2, and an op. And we're just going to use all those as strings for now. We'll convert to numbers later. And that'll just allow us to easily pass around these things. And what we're going to do is we're going to store a hash map so I can say, hey, I have an output A, give me the gate that generates A. And that way, and then I can look and say, oh, to generate A, I need to know B and C. Well, give me the gates to generate B, give me the gates to generate C. And this is turning into a really nice recursive algorithm we can use. So we're going to generate this gate object. We're going to have to create we'll use a from. We've done this in a couple previous videos to read it from a string into a gate. Then we will use a hash map, and we'll iterate through all the lines in the input using the output value as the key and then the gate as the value. And again, now I can start working backwards. I'm going to need a second hash map because there's actually, if I just ran like this and just said, okay, recursively A needs B and C, now B needs D and E, go get D, and just recursively work down, I'd end up doing a ton of repeating. And so I'm going to use another hash map as kind of a cache to say, oh, I've already found that when I want to know what X is, it goes 7 layers down, but it gets this value. So I'm just going to use the value again. And that'll make this solvable in reasonable time. And then I just need some way to say, actually run through those traps and calculate it, and call that function. So let's go ahead and jump into VS Code. We're going to start with my genday script here for day 7. This basically just builds me a new package here, gets the advent of code stuff, and gives me a nice stub to start a main.rs. If you want more information about this, go check out my day 0 video where I kind of did an introduction to Rust. So now let's start. We're going to make a gate object. So we'll do struct gate, and we're going to just simply have an in1 string, in2 string, and an op string. I could try to, my first gut when I was doing this was to try to include the out as well in here, but I really don't need the out. I want the out at the other as the key to the hash map, and so I'm not going to bother trying to include that in there. What I do need is, let's go ahead and grab from the input, let's grab something like this, and make sure we can start parsing it. So we're going to, just for now, we're going to let data equals that. And now we want to be able to parse this. And so I'm going to go ahead and start parsing directly into a impl from, and it's going to take in a string object for gate. If I can type. This will have a function from, we'll call it s string, and returns a gate. So we're going to say, first thing we want to do is when we look at this string is we need to split it to, let's go back a second. I don't think we're going to split it here. because I just went through saying we're going to actually split. We actually just want to pass this string in. So let's come down here, and we will get. Let's see, we can say let maybe we'll do input output equals line dot split once. And now we can do split once on that arrow dot unwrap. And now surprised not getting any typing out of that, but if I need to restart my, let's see real quick. I don't know if it's just my installation or what, but I crashed. All right. So we got our input and output here are just going to be strings. And now we can do something like, we'll do something like let g gate equals input dot into. So that should give us a gate if this function, when this function works. So we're going to input right now is going to be, in this case, et r shift 2. So we want to be able to, okay, oops, let me go back that far. We need to be able to handle the biggest challenge is going to be there's different ops have different setups, right? So in our case here, we've got 3 words or 3 things here. So it's all going to depend on what what it looks like when we split it. So we'll say let svec equals s dot split dot collect. Oops, collection. Let's see if that works. And I might need to type that, but we'll try it for now. So we have this vector that's going to be the split. And so if we can start off by saying, again, let's look at the different kinds of input we're going to deal with. Almost always, I think almost always the operation is going to be in the middle, the one index, except for not. So let's do an explicit check for that. So we can say if svec sub 0 equals not, and if that's the case, we're going to say gate op. It's going to be svec sub 0 dot to string. Oops. It's not. Oops, that's not what I want. I'm gonna go ahead and it's not happy with the way it's typing, so I'm just gonna come in here and define this spec. And this is going to be this kind of string. I wonder if that'll help me with my typing. So now we can do in1, and this is going to be s underscore vec 1 to string. And then in2 doesn't matter in this case. We're not going to use it, right? So I'm just going to make it an empty string, and I still got to make it a string because that's what I chose to use up here. That could also be the problem we're having here. All right, we got an error here. What's going on? Oh, if without else. Okay, that's fine. We're going to fix that. And so now we'll say else, and we'll do a gate. And in this case, we are just going to say op is svec 1, because it's in the middle. Again, not with a in1 is svec 0 dot to string, and in2 is svec 2 to string, not to ASCII lowercase. And that solves that. So basically, we're going to parse it, and either it's going to be that or that. And if that's the case, we're going to get, I don't know why I wrote a line. Well, I do. I'm going to be going over that later. In fact, let's do this. Let's do line here and line here. That's what I meant. I'm in the habit of doing lines, right? Okay, so now output there. Get a G is input into. And we can put like output here and G here Let's see if we can print our gate. It's not going to like that, I bet. Here we're going to do cargo run. Let's see. Day 07. Okay, so what's our error going to be here? Gate cannot be formatted with the default formatter. I can try using the debug formatter, but it's not going to work, I don't think, because we haven't implemented debug. But it tells us, so gate cannot be formatted using that. But then it tells us down here, consider adding derive debug to gate. So we're going to go ahead and do that. We're going to do it with the right copy. If we just add to our gate this derive debug, it gets with it the ability to debug print it. And so now when we cargo run it, we get EU, and then we get our gate coming out that looks like ET2 with an R shift. So that's pretty cool. So it seems the parsing seems to be working. Let's go ahead and now that we have that working on one line, let's go ahead and get rid of this, and we'll do for line in data.lines. And now we can pop this in. And again, we're just going to generate a bunch of gates, which presumably we'll then do something with. But let's for now just try that. Where G is no longer going to be good there because we don't have that. In fact, output's no longer good there. Let's just we just want to run this and make sure it works. And it's mad at us for not finding all of these. It's not using them. Okay. Cool. Maybe we could do something like print line on the G. Now we are going to try to actually print all these. Oh, we're going to print debug, print those. And we actually panic here. And that's good because we did miss something. We got through a lot of instructions, but then we get down to something else, and we get the length. The length is one, but the index is one. So we're reading out of the length out of the thing. We can do another. Let's see what. Okay, so what are we breaking on here? We can say line. Go ahead and print line in first. And so the line that we're breaking on. Interesting. We break. Oh, well, let's print. We're still failing. So let's print up here before we crash, so we can actually see the line. So the line we're breaking on here is a value into a number, and so we didn't account for this. So let's come up here, and again we can say, I think it's else if, like that. Gate. Is that not how I do an else if in here? That. No, that doesn't look right. Let's just try this real quick. Maybe. So else if. Oh, because I didn't define the if. Let's say svec.len equals 1. I'm gonna assume, hopefully good here, that if there's only one thing into an arrow, that it's just gonna be the op is just gonna be, we're gonna call it none. The in1 is going to be svec 0. And the in2 is going to be just like above. Like that. Like that. And now we can run again. And we get all the way to the end here without any crashes at least. So we're feeling pretty good that we got all the stuff here. So now we can read all of the gates into gate objects. So the next thing we want to do is we want to create a hash map that will store the output mapped to the gate that it goes with. We could just create a hash map, but I want to actually create some functions associated with it. So I'm going to create another struct. And we'll come here and we'll do a struct. And we'll just call this like challenge. This is like our overall game. And in here, we're going to have commands, hash map. Let me import this too. And it's going to take a string and a gate. Now, I lost a lot of time, like time that would have been really boring to be watching on YouTube, making this a pointer to an str, and it led to all sorts of borrowing issues and ownership issues and inheritance issues, or not inheritance, ownership. And ownership and is like one of the hardest concepts to trace in Rust, especially if you're just getting started. I still struggle with it a lot, but it turns out, so the simple answer is this. A string here is like stored on the stack. It's a value, and you point to it, and you get it's got an address that starts it, and it is that value stored on the stack. A str is a pointer to, so I shouldn't have said pointer in the first one. The string is a value stored on the stack. An str is a pointer to some space that may have some string. It can be a slice, it can be a substring, but it's a pointer. And so if I make these strings, what happens is when I grab one of them, I'm now getting a pointer to something that, and therefore the system has to says, oh, you're holding onto this pointer to this object. You now have ownership of that whole object. And so when I call a function where I pass in self, and I'll do this later, and I want to do like recursive calling, just reading strings out of it causes the ownership to change. Versus if I use this string, which is just some space on the stack, I can very easily say, just give me that space on the stack, or let me create another bit of it, and I don't have to worry about it anymore. And so making this a string is just way cleaner for using it for keys like this. Hopefully that makes some sense. This is all still, these concepts are a little bit to me as it is. So, okay, we need standard, I think it's, what's it, collections? HashMap, yeah, okay. So we're gonna import HashMap there. And now we've got a HashMap here. We're going to do impl challenge, and we'll do function new, because we want, it's just, let's have a clean way to create challenges, and that will go to self, and that will mean we'll return a self of commands HashMap new. All right, and so now we can come down here on our main, and we can say let chal equals challenge new. And so I've got a new challenge. And what we're going to then do is, oh, and we're going to want to make this mutable for sure, because we're going to be updating it. So we'll save that. And then we'll come down here, and instead of printing our gate, what we're going to do is we're going to say chal dot commands. Now we have a hash map. And then we're going to do an insert. And our key is going to be output to string. And our value is going to be input.into. And because, let's see, so we can get rid of this. We don't need the G. We do need to make sure that this is typed. Oh yeah, we did. Okay, so because the chal commands, it knows it's looking for a gate here. We can, we've already defined that. So we can just do input.into. And now we're going to fill up our challenge hash map. So we should, at the end of this, have this giant list of things. In fact, we'll come down here, let's try it. Chal, we're definitely going to need a debug print on that. Let's do chal.commands. That way we're, because I don't, yeah, that'll work. And now when we run this, we have this cool, we don't need to go through all of it, but you can see, if I want JQ or JG, I know the input is IU, the input is JF, and they're ORed together. And so I've got all of those read in. So now I've taken the whole problem and I've mapped it into a way that I can easily use it, right? So now I need to create a get value function, right? So now I'm going to do that that's going to be part of the challenge. So we're going to come down here and we're going to say, we're going to need a new function. Oh, I was like, that looked weird. So we'll do function get value, and it's going to take self, itself, and it's going to take a node, which will be a string. And it's going to return a U16. I think I read this in the challenge, but these are all 16-bit values. So it's important that we think of them that way. And so what I'm going to do here, so I'm going to say if node.chars, if I get all the characters, .all, and I say C, for all characters, so that the way you do all is you give it a C, in which case is a char, and we say C.is ASCII digit. So if every character in C, in the string node, is a digit, then I've got a number here. And if I'm just trying to find out what the value of a number is, it's going to be that number. So I'm going to do return node.parse. That's how I turn it into a U16. And if I'm actually going to tell it that, like this, U16. And that'll return a result, which we need to unwrap, and that's the end. So if I get something that's just a number, I'm going to return it as a number. Next thing I want, so now let's go ahead and say, like, we'll say let g equals self.commands dot get node. Let's see, so I've got an option there. We'll unwrap it. And now I'm getting a gate. I'm getting a pointer to a gate. It doesn't like my node here. Let's see. Node needs to be a string. Consider borrowing here. Okay, let's do what the compiler is telling us to do. So now I've got a G. That's cool. I can do let v1 equals self.get value. So I'm going to call this myself. And now I'm going to say g dot in one. So what this is going to do to me is it's either going to say, let's say it's like, I'm trying to get A. Let's say it's B or C. Well, it's going to say, okay, well, G1 is B. So pass this back in and figure out what B is. Or if A was just like 3 equals A, well, now I'm going to pass the 3 in there and I'm going to get the 3. But either way, I'm going to get back a U16 here into V1, which is what I want. I can do let op equals G dot op dot as, do we want op as a string or as a, oh, okay. Well, so let's just do it like this for now. So I've got this op as a string. And now I can do let results equals match op, and this is as string, because I need to match on strings. I think that'll work. Well, it doesn't, it's yelling, it's not happy about that. Let's see. Missing match. Oh, okay, it's just not happy on a match. Okay, so let's see. Our default, there's a few different things we're going to get here. Let's say I've only read v1, and the reason I've done that is because I don't need v2 in all cases, right? So there's a few cases where I do need only need v1. So let's say, for example, if our op is none, then we're just going to return v1, right? So that's the case where, like, my node I'm passing in is just like 6,000 equals x. So my gate is going to be, my v1 is going to be 6,000. My op is going to be none. I'm just going to return 6,000. You know, so this gets the value as a number 6,000, and I'm just going to return v1. So I'm done. The other one I need to worry about here is not. If I get not, I want to return simply not v1, and that's, you do that with the exclamation point. So nice and done. The base case is going to be everything else. So I'm going to do that and try this again, everything else. And I'm going to put this here because I'm going to do, now I want to read v2. So I'll say let v2 equals self.getValue. And this will be g dot in 2. Now I'm reading in G. Now I'm reading in 2. It doesn't like this. Why? Oh, because I'm not returning anything yet. That's fine. Okay. And so now I'm going to do a match on op again. As, in fact, let's just do it once here so we don't have to do it twice. Now I can do a match on op. That will be a little bit cleaner to read. And now I got to cover the other cases, right? So we can do something simple. If we don't want to look those up, we can just say, like, let this go here. The default case in this case is going to be panic unhandled op like this, and then we'll do g.op like that. Let's see, are we failing here? What don't we like? It was just match arm without braces. Not quite sure about, oh, I don't put that there. That's cool. So now we could do something as simple, you know, we know there's at least a few. So let's come in here, we can do or In this case, we're just going to return v1 or v2. We have and. We're going to return v1 and v2. And again, these are just the operations for bitwise stuff. And if we forget here what we're dealing with, let's see, we do have an error still. Not quite sure what it is though. Let's run it and see. Expected U16 found. Do I need to say return? Or do I have a semicolon where I don't want one? Let's see. Result. Oh, let's say result. There. So now I do need a semicolon here. Now we're returning result. I probably could just, in fact, let's try this. I think I can just take this off and get rid of this. And now this whole match op is the return value. Let's see. Cannot move out of G1 but has a shared reference. Interesting. Okay, so I think this gets back to the discussion earlier. You can see here that I'm getting a pointer to a gate. And when I get a pointer to that gate is stored in self. And so that's going to take ownership over a lot of over self really. And over all this stuff. And what I want to do is not actually have that ownership. I want to instead, if we just do a clone on this, and save, now, let's see, it didn't, oh, I think if I run this, it's going to show me a failure. Interestingly, it doesn't complain yet. This is weird that it doesn't give, oh, here we go. Let's come up here. For that clone to work, and I wish it would tell me that, I have to also implement clone up here. So if I save that like that, now it works. And so what happens is, you see this turns to an actual gate. And so what's happening is, instead of getting a pointer to this thing that's buried in my big structure, it then says, oh, okay, well, now I'll just copy this one little part of it. And so now I have a new gate stored somewhere else. And I don't have to worry about in any of the ownership stuff associated with all the stuff I got. And that means it'll make this other stuff work fine. So if this is going to work, we can, it's not, because I don't think we've implemented all the stuff here, but let's just, for the sake of argument, show, we can come down here and we can say chal.get value. And what I wanted they want me to find the value of A. Let's just try that. And it needs to be toString. And let's run this. And we get, here we go. So we have our thread main panicked at unhandled op L shift. Perfect. So we can come in here. We can do L shift. And that would be V1 left shifted V2. We can run it again. It's going to complete on R shift for sure. Yep. So we need R shift. And that's going to be V1 right shifted V2. And okay, so here we're hanging in, where am I printing? Oh, I'm printing when I'm building, right? Let's get rid of this line. We don't need this anymore. Here it's going to hang and it's going to run forever. And the reason is, I mean, not forever, hypothetically it will solve, but the reason is it's just going to be doing things over and over and over again. And I need to put some way to shortcut this in here. And so what I'm going to do here is I'm going to come down here and I'm going to say values. Let's make this a hash map of string comma U16. And we'll define this as values hash map. Come on, you can do it. New. So now I've got two hash maps. And what I'm going to do here is I'm going to say, we're going to come down here to the bottom. And this, let's see, we're going to say let result equals. We're back to having our result now. And down here, we're going to close that. And we're going to say values. Oops, let's see. Self.values dot insert node dot toString comma result. So now what we've done is we're going to, after we calculate, we go through all the trouble here to calculate this result. So we know that if we get the value of the node Q, the result is going to be this. And we're going to then, we're going to return result. Make sure, like that should make it happy. What don't we like about here? I'll come back in a second. So we're going to save into this hash the value that Q is 17, or whatever it is, right? And then we're going to return result like we did before. So what we need to do up here is at the top, we're going to say if, let's see, self.values.contains key, that's what we're looking for. And we'll do node there as well. So if that key is already there, we can just return self.values.get node. What is that going to look like? Oh, okay. So you can see right now, this says it's expected type U16. It's getting an option, a pointer to a U16. So to get rid of the option, we will do simply an unwrap. We save that. Now it's expecting a U16. Come on, error. I was expecting U16. Let's make this easier. We'll do let x equals, and we'll save this. And now we're getting a pointer to a U16. So we want to dereference that like that. And now we're getting a U16. And so now we can just say return that. Now we return. So if it's in the thing, we just right away get it and return it. And that you know, it doesn't sound like that big a deal if we have a number coming in, but if we've gone 20 layers down and then come back up, you know, now we've saved a lot of execution time, and that'll make this solvable. So what's our problem here? Self is a reference and data cannot be borrowed as mutable. Oh, okay. So I'm passing into this function self. I need to pass actually mutable self. I think that'll actually solve this. All right. I don't know how. I love it when the thing adds in. Oh, because I accidentally added hash, I think, at some point. Let's get rid of this. But we have an answer. Let's see. An answer is correct, so we've got an answer. Cool. Let's check out part 2. Now take the signal you got on wire A, override wire B to that signal, and reset all the other wires, including A. What is the new signal ultimately provided to wire A? Okay. So what are we going to do? We're going to add one more function to our challenge. Let's go down here to our challenge. We got our get value. And we're going to add function reset part 2. And we're going to have our B, which is a string value. Actually, it's going to be a U16. We're going to pass in the U16, the value from before, and we're not going to return anything. And so what we're going to do, they said to set, so we need to do, oh, we need self. Self. Okay, so first we need to come in here and self dot commands dot get. Is that what it is? No, it's not get. It's oh, man, it's gonna bug me. Self dot commands dot entry. Entry for the value B. That I think that needs to be a string. That we're gonna get self dot. What do I like about that? Okay. Oops, they're using a semicolon, of course, because we can't return anything. So that is, we're gonna get that thing to string. We should call the function, and then we're going to equals B here dot to string. So now we're going to save B. Is that how we do? Is that how we do? How we send? I don't think that's. I think we have to do like that or modify thing we did in the previous one. Let's go back here to when do we do a hash map? Was that in 2? Nope, 3. So we put, there we go, and so we get the entry with the thing, and then we do and modify, and we take the value, and then we do what we wanted to return it. Okay. So we do this dot and modify. It's going to have some value x, and we're going to make it x equals. Oh, we're just going to. We don't care what the x is. We're just going to make it b. Does that look right? 2, don't need 3. Oof, we did want 3. Yeah, what's wrong with this? Let's see. Mismatch closing delimiter. Well, okay, that helps. Let's see. That closes entry there and modify. We just need 1. We want b dot 2 dot 2 string. Let me say x equals b dot 2 string. Expected muck gate found string. Oh, because we don't want, okay, so b is a gate. So we want the b dot okay, we need to do a little bit more here. Let's do this. Let's make this look a little prettier. And modify this. I hope we can do that, because we're going to need to x dot, so x is our gate. So x dot in 1 equals b dot 2 string. X dot in 2 equals that dot 2 string. X dot op equals none. Of course, dot 2 string. Is that going to work for me here? We are changing self, so we need to make this mutable. And okay, I think that might have worked, or at least it compiles. So basically, what we're going to do is we're going to go ahead and get in our commands, we're going to get this, and we're going to change b to be this none operation with the value that we pass in. The other thing we need to do is we need to do self.values equals HashMap. We're just going to wipe this, right? So we're just going to do HashMap new. So there are no values now. So we're going to run the whole thing twice, basically. And so if we come down here, we can say let part1 equals this. Come down here, we can do part1. And now we say shall dot reset part2, passing in part1. And then we can say shall dot get value of a dot 2 string. Okay, so effectively what we've done, we calculate part1, we print it. We're happy with that, it worked before. Then we're going to reset to ourselves the challenge for part2, passing in part1. And we're going to change the B entry to be this value. Let's call this part1. Part1. So there. We're going to pass in the part1 value. We're going to find the B thing in our commands, and we're going to update it so that it's a pointer basically to the part1 value. Then we're going to reset all our values and rerun the whole thing again and get a part2. And if this works, we will have that. Let's see. Let part1 challenge equal, we need a semicolon. And if this works, we will have answers 2797. 2797. Sweet. I guess that's it. Just a wrap up, I kind of just did. Yeah, that was a tricky one. I spent a lot of time. The big thing to remember is if you're going to use things like, especially if you're going to be involved in like complicated things where you have structs with structs in them, and then you're going to be passing self around. You really want to try to use strings for keys and not STRs, just because it makes it simpler. makes it easier to not be stuck with ownership issues. So that's my big takeaway. Thanks for sticking around with me till the end. I will talk to you next time.